Yeah, good morning, everyone. And happy to be here in AusNOG for the first time. Though I'm missing the dot here, please feel free to meet me. I'm happy to meet all of you. So I'll be here actually to sharing some of the experience. We are uh, maintaining a large network, I should say. And with the growth, facing some challenges which usually not there earlier. So some maybe already face that problem, and some may be facing in the future. Jeff was talking about applications only, but I'm from the purely from network side, the poor guys who are maintaining the network, delivering the traffic smoothly to the end users. So I'm from Bangladesh. You know that it's a tiny little country. I'm just trying to compare. The size is actually 1/5 of New South Wales. And population-wise, it is, I think, almost 7 times bigger than whole Australia. So it's a very unique situation. And so challenges are a bit different from here. And you know that network is growing everywhere, actually. The traffic growing rapidly. And if you look at the slide that from comparison for last 12 years, that it was 3.6 million, and now it's 124 million internet users in Bangladesh. And around 60,000 kilometers of fiber throughout the country. And bandwidth grows from 7.5 gigabit per second to 4.5 Tbps at this moment, in fact, last year. So it's growing pretty fast. And you can see the coverage. We are covering the almost the whole country, except some hilly part on the east, and at the bottom southwest part, where Royal Bengal Tiger lives, so we don't have any network there. So if we talk about fiber at home, that we have a DWDM network carrying huge traffic, mostly using 3 vendors, and we have IP/MPLS network, around 9,000 routers, and other network devices. So in terms of devices, it's actually quite a large network. And if we talk about the service, what we're offering is basically we are providing backhaul services for the ISPs and telcos. We are in between, not connecting the, talking with the end users, but offering services to the ISPs and telcos to carry their backhaul traffic. And we're providing L2 and L3 VPN services, basically for their IP RAN backhaul and for backhaul connecting the different cities. Also, we have data center providing co-location services, and planning to go for the public cloud service very soon. But I'll talk mostly on the IP network part today, that the experience with the growth. And we know that IP network usually is very simple, that you run a few protocols, so you're ready to go. But when network grows, the complexity actually starts from there. And I'll be talking actually some experience, some exploding experience at different time, different situation with these different things. They're not very well connected, but probably I might hear from something good. Maybe it could be done in a better way, but we have done it in our way. And probably somebody will face this in their future. So when we started in around 2009-10 time, mostly the ISPs are the client. And it was fine. But when we started doing mobile backhauling, then challenges come of fast convergence, that they do not allow a single packet to drop, because the call will drop, user will be annoyed. And started tuning IGP, BGP parameters, added BFD for link failure. Then we added LFFR for micro-loop avoidance, because for a transient time, in a ring environment, if a link fails, it takes some time to converge. So to avoid that, we use LFFR. And also BGP peak. I'll not talk detail about that, because it's a pretty old thing. Probably all of you know about that. But when the network is growing, and when deployed around 2,000 plus router, we found that IGB prefix is too much for the cell site routers, because they have a small memory and it cannot handle. Then we started following some best practices. These are common, but most of us, we are lazy and we do not do good things. So we had to filter the point-to-point link prefixes, and only the loopback is allowed. So the IGP size become reduced, and it's working again nicely. But with the growth, we found that the access routers have become slow again, and we didn't find any valid reason what's happening there. Then we noticed that if there is a single link failure throughout the network, it actually impacts performance of the other routers. And so, for example, if this router usually sending all these updates, and if there is a particular link failure, then it actually sending all the updates to all the routers. And everybody's taking some time to process the change in the network. So what we did actually that we added a route target filter in the route reflector. So it only sends the destination that needs that update. So the other routers are simply not impacted for that slight changes in the network. And we always see every day at least 50 to 100 fiber cut in different part of the country, because there's a lot of development work is going on, and the weather is not very normal all the time, so a lot of rain, a lot of thunderstorm, so a lot of fiber cuts and a lot of interruption in the network. So introducing this route target filter, so what router does actually, route reflector does only, that it only sends update where it's needed. In the rest of the places, it doesn't send anything. So it eases the network, and we found a good outcome that network become much stable. So I'll be sharing another experience actually that is very special in nature, that usually we see that any link failure, the convergence time is sub-second level. Usually 50 to 70 milliseconds we see convergence, so no traffic sees any interruption. But in a very special case, we suddenly noticed that if a fiber cut here, then it takes around 60 to 180 seconds to converge. So there is a two client-side router. It is a backup link. The traffic should switch instantly. But what happened that if this link failed, in between you see the cross mark there, there's no pointer, then traffic usually oh, I'm going in the back direction. Sorry for a lot of oh, this was fine. It's the old slide I'm traversing. Okay. So you see that traffic is flowing from the counter router to the other side. The route reflector is not updating its prefixes because it is not getting BGP signal after 180 seconds, maximum 180 seconds. So it's taking time to converge, and after 180 seconds, traffic actually following the backup path. The new traffic flow is going on. So that led us to what to do. And the solution we found that multi-hop BFD. You know, BFD actually identify link failure pretty fast and tell other protocols. But here, the RR is actually far away from the link failure, and it's not getting the BFD signal. Then we have introduced multi-hop BFD to send this signal to the RR instantly so that it doesn't wait for the BGP to update. When it gets the BFD signal, and it actually converges. It's far away, so we have used around 200 millisecond delay for the BFD timer, and we're able to converge in sub-second level. So took some time to, okay. And next move to the, am I going too fast or is this fine or going more technical? Yeah, thank you. So, you know, we all use route reflector in a network. And in our network, we have around 30 to 40 route reflector that actually handling all the routing among the routers. We have mentioned that we have around 9,000 routers running in our network. So, and it was initially just fine as a generic flat RR. Each are pairing with each other as the standard BGP practice we do, and it was fine. Last year, we got an order for around 15,000 new cell sites to connect. And while finishing that thing, we found that if there is a link failure, the RR is not actually sending the updates. There's some stall prefix in the RR, and we see outage. And we talked with the vendor. Everything's fine. Every configuration is right. There's no problem. It should work perfectly. They have recommenders change the iOS sometimes. We've done that. Nothing happened. Then we thought that it could be the scaling issue because it happened after adding around 1,000 new routers. So we thought we should change the architecture. It was simple, probably good for a small network, but may not be good for a larger network. Then actually we switched to hierarchical RR design so that we have a two central RR, and then there are different regional route reflector, so that we split the route reflector function into different parts. And eventually, we found that it's become much reliable and robust, and we don't see any problem in the route reflector side after switching to the hierarchical route reflector model design. And so we're working fast, and along with that, I already mentioned that RT filter, and the cluster ID actually preventing from routing information loop arising, and community filter actually to reduce before signaling to central RR and to the regional route reflector. And we found that we were using actually Cisco ASR 9001 routers for this RR functioning, but and we found that it's not really able to handle actually that scaling issue with these huge prefixes. So when you try to go for the newer model, the router costs are actually humongous. If you have a lot of memory and a lot of CPU with that, then we thought we should have a change. Let's move to server-based route reflector. There are a lot of open software like FRR, like Bird, and also the vendor-driven like Cisco IXXRV or something to use that route reflector. And it found that they're really functioning very well if you move to router-based route reflector to server-based route reflector. And you don't need that forwarding plane capacity at all, because it's only exchanging the information. And cost-wise, you can see that how much savings in the right corner, that if you just move from the router-based RR to a server-based RR. Next, move to another typical challenge. I think most of us probably have already faced it, because when we introduce DWDM in our network, we are carrying around, at this moment, around 20 terabits of traffic in the DWDM network. The problem arises for the long-distance links. If there is a fiber cut in the primary path, theoretically, it switches in 50 milliseconds. But somehow, router fails to recognize. So user sees an interruption, especially in an international circuit. If there is a flap in a BGP, it takes 5 to 7 minutes to converge. So it's a huge outage. And talking with vendor, talking with a lot of data analysis, nothing happened. But finally, we find a kind of solutions that in a DWDM interfaces, it has 3 different modes, actually. There's one called OPU, GFP, and GFPP. If we choose GFPP mode, then actually router is carrier data parameter actually syncs with that, and the problem resolved. And it happened with all the vendors. Like we tried with Huawei, we tried with Infinera, with Nokia. So all the vendors have the similar issue. And after doing this, we find that, yes, the BGP is not flapping anymore, and user get uninterrupted services from there. So I'll talk about another. I'm jumping from here to there in different places because sharing some of the experience we found it could be interesting for others. So that's why sharing all this. This is about QoS deployment. I know network people doesn't like QoS. We like to increase the capacity and try to keep the network simple. But in a situation where even in between, you're serving different operators, have different priority on their traffic. You have no choice but deploying QoS to your network. And the problem arises, like for one operator, they ask for QoS. OK, fine, we deployed. And they're complaining, you're changing our DSCP bits. What? What's happening? Then we found that they're using one vendor. Our network mostly built on Cisco. It's a different vendor. And it's basically, when traversing to the MPLS network, it's changing the DSCP bit, because the mapping is different for two vendors for different types of services. So then we found a workaround that actually we need to change the DSCP change from pipe mode to level per FRF mode. And in that case, we found that, yes, what DSCP value the client is sending, we are mapping to EXP MPLS bit, and when we are delivering to the other side, to the telco aggregation side, it's not changing the value. Things resolved. But again, the different operator, different telco operators, no, they have the deep priority on the different traffics. They do not want to have the same. Someone say, I want to prioritize AF11 DSP bit. Someone say, no, I need CS7 to be prioritized. So to resolve that, what we did actually, we done a customized mapping in the EXP level. We have our own table that these are the priority table. So whenever the traffic entering for a particular operator, based on the choice, we are putting their priority table to our priority queue. So that's how actually we had to address that multi-vendor situation and multi-operator environment to handle the QoS thing. It took some time, took some hard work, took some complaint from the clients. It's not working, what you're doing, but eventually able to sort it out by this way. And this is another interesting example, very silly, but effective. Like we are using MRTG cat key for a long, long time to see our network utilizations. But, oops, still in the old slide? OK, sorry. But we started getting complaints from our client that we are getting packet drops in our network. And the graph shows the utilization is significantly less than the maximum traffic. What's happening there? And then we realized that actually this MRTG CACT, they actually pull data in 5-minute interval. So you're actually getting a 5-minute average traffic. It was OK in early days, but nowadays, with the change of the content, there's a lot of small micro-level burst in the network. And actually, packet get dropped. It is not captured in this MRTG or PRTG graph, but you'll notice that actually the packet is dropping. So we tried to implement telemetry-based measuring. And if you look at the graph, that if you take data in 30-second interval, then in this particular length, the maximum utilization is 15 Mbps. But if you take 5-second interval, the peak is actually 33 Mbps. So how we are measuring at what time interval, it's giving completely different data. And some real-life link, we have seen that a client subscribed, say, 500 Mbps for a particular cell site. Actually, the burst is going up to 1 Gbps kind of traffic. So they are noticing their packet is being dropped. But if you see ICMP ping or any other tools, everything's fine. So we switched to this telemetry-based monitoring. And actually, it's helping us to find the actual utilization. And it helps to troubleshoot the network and help to plan to upgrade your network faster when actually you need to upgrade. And also creating business opportunity, actually, because we are charging less for providing more capacity. And in a network, there will be interruptions, there will be fiber cut. And one, in a fiber network, one issue is that managing high losses. Sometimes fiber bends, sometimes fiber deteriorates quality, sometimes the joints become weak, and there are high loss. And one of the main problems with us was that in one link, there is a high loss, that is a backup link. When the primary link gets cut, traffic tries to shift to the backup link, and it doesn't work because already the high loss. But as per NMS, we are saying the links are up because it's good enough for the router to sense the connectivity for their control traffic, it's fine. But when the real traffic enters, link goes down. So we usually used to look at the NMS, that what is the high loss, what is the, and OpenTT, and solve it. But very often that we see a lot of interaction still causing that. So we try to do it again using the telemetry to get the data and put a threshold. You know, to reduce cost, in many cases we use a lot of third-party SAPs because they're much cheaper, but they're a bit unreliable as well. So all the time, the threshold value actually doesn't work. So we had to customize our own threshold value, and we have our own database. So every 15 minutes is pulling all the data and checking which link is crossing the threshold. Then it's automatically opening the travel ticket, and it is fixed by the service team. And we found that after doing that, our complaint reduced from around 15% to 6%, only because of just single automation techniques and developed by us, and it's a huge positive feedback from our clients. And that leads to actually do some more automation thing by us, that to get customized information, get more visibility. And now actually we're working that not only the links, to get the protocol visibility, that if there are any changes in the protocols and any anomaly there. And in a big network, service provisioning was a challenge when you're deploying new sites. If you want to do configure manually, it takes a lot of time and effort. And the chance of error by the people who are configuring is much more higher. And regarding visibility, that when actually you plan for upgrade, so in the lower graph, you can see that it's giving a small summary of actually what links actually, what is the utilization. If something goes beyond 80% or above, it's in red so that you can flag it and you can do immediate action to upgrade the capacity or reroute the traffic in other direction. So that saves unintended interruption or the degradation of the quality of services. And also the automatic provisioning and any update, like usually the vendor nowadays is actually offering a lot of new OS 3-4 times in a year. And if you want to upgrade your 9,000 router manually, it's technically impossible. So doing a bit of automation actually saves our life. And that's how we are now configuring and managing our network. So, but still, as the network growing, we are now considering whether we can split our network into different parts. Though it's a small country, but if you can, presently it's a single AS network. But again, any change in one side, we always need to worry about that, whether it will impact the other part of the network. So this is a thought we're considering, and we're testing that if you can divide into multiple ASs. Am I running out of time, or I'm going fast? Cool, thank you. So we're trying to split our network in different parts. We tested in our lab and seems working fine. So it will reduce the headache of change, and also it help to have multi-vendor actually, that in a different part you can have different vendors, because syncing with a different vendor in especially some parameter is still a very challenging situation. So this is something we are about to deploy. And another thing we are really considering for next year, that is whether we should go for SRMPLS or SRv6. We are doing our R&D. Some vendors are really pursuing for SRMPLS, saying SRv6 is not ready yet. There are some vendors, they're saying, why trying that? Move ahead to SRv6. So really don't have any good answer. And like to hear from you if anybody have any experience. And I've tried to say what we have done in our part, but if you have any other better solution, ready to hear that, and we'll be happy to deploy that. And the network is still growing, and next year we're expecting around 2,000 plus router. Probably we'll see some newer challenges in the coming years. And that's how network as life goes on, and we have to live with it. Thank you very much.